We're talking about what if I have two populations and I want to know how different they are. What is their difference? I want to estimate the difference in their averages. So the interval formula is x bar 1 minus x bar 2. That would be the middle of the interval. X bar 1 minus x bar 2. That's the middle of the interval. Then I would add and subtract the t star critical value, times the standard error. Now, the standard error is on your formula chart, and you can see it right here in this second line of your paper there. That is the standard error for combined distributions. And so it would be the super square root of s sub x1 squared divided by n1 plus s sub x2 squared divided by n2. So remember, when we combine standard deviations, we have to square them, add them, take the square root, just like the Pythagorean theorem. And I know you guys look at that formula and you go, look, lady, I did not sign up for pre-cal for a reason. So I want you to not worry too much about this formula because you're going to use your calculator. So on your calculator, to get the confidence interval for a difference between two population means, you're going to go to stat, test, and it's number 0. And it says for sample, t int for interval. This is where you're going to go on your calculator, and it's going to calculate this interval for you. And all you're going to have to do is just put in whatever data you've got from the problem. Okay? So just to make sure you guys know, for one population, that's what we did earlier this week. And then for two populations, that's what's on this second line here. Okay? That's just the difference between the means. That's the mean of the distribution, and the standard deviation is over there. Cool? All right, so that's all the theoretical junk. Now let's actually do a problem, okay? Okay, here we go. Let's do a problem. Yay. You guys ever heard of Katy Perry and Justin Timberlake? Yep, definitely your childhood, right? All right, so students wondered whose Twitter account gets more likes on average. Is it Katy Perry's or Justin Timberlake's? The students selected a random sample of 15 tweets from Katy Perry and a separate random sample of 15 tweets from Justin Timberlake and recorded the number of likes for each tweet. Look at this, you guys. The box plots of the data showed no outliers or strong skewness. Do you know what that just did for you? That made it where you don't have to make a box plot. Aren't you excited? I can tell. You've never been so excited in your life. I can tell right now. Here are the results. Katy Perry, with her sample size of 15, she had an average likes of 7,193 on each of her tweets, with a standard deviation of 1749. Justin Timberlake had an average of 6,393 with a standard deviation of 3,407. Now, who gets more likes on average? Katy Perry, but look at the standard deviation for Justin Timberlake. He's got a bigger standard deviation. So who really gets more likes on average? That's why we're going to construct and interpret a 95% confidence interval for the mean difference in the number of likes for the celebrities' tweets. Now, if there is a possibility that Justin Timberlake and Katy Perry get the same amount of likes on average, then what number would show up in our interval? 0. Let me say it again. If it's possible that Katy Perry and Justin Timberlake get the same amount of likes on average, then what number would show up in our interval? 0. Because if they're getting the same number on average and we look at the difference, we would get a 0. So we're looking to see if we get a 0 in our interval. We'll see here in just a minute. Construct and interpret. What do we get to do when we construct and interpret? State, plan, do, conclude. Let's go. State. Yes, we will estimate the true mean difference. And we're going to say here mu1 minus mu2. Mu1 minus mu2, because we are estimating the true population difference, but we're going to use sample data to do that. We will estimate the true mean difference between, I'm going to abbreviate Katy Perry KP, is that okay? But no? Okay. Between Katy Perry and Justin Timberlake, JT. We will estimate the true mean difference between Katy Perry and Justin Timberlake's Twitter likes with 95% confidence. Now, you guys know that usually there's always a little tweak when we do a new state plan do conclude. And so here's the tweak. Because of the fact that we have two populations, a mu1 and a mu2, we do need to define which one is which. So, who do you want to be mu1? KP. Mu1 equals the true mean likes for Katy Perry, KP. Mu2 equals the true mean likes for Justin Timberlake, JT. So I've defined my mu1 and mu2, so I know which one is which. Thank you. And I have said what I'm going to do. I'm going to estimate the true mean difference between their likes at a 95% confidence level. Any questions about state? I'll take that as a no. Are you guys ready to plan? Okay. So excited for Friday. Whoops, my bad. All right, we're planning. Y'all just keep going. I just had to refresh because I was out of room. Plan. Random. Do we have an SRS?
Yes.
We sure do. Whoa, we have an SRS of 15 of Katy Perry's tweets. And we have an SRS of 15 of Justin Timberlake's tweets. Yay, it's almost like we get to do everything twice. So fun. 10%. 10 times 15 is 150. Do you think that that is less than the population of Katy Perry's tweets?
Yes.
I would think so. 10 times 15 is 150. Do you think that's less than the population of Justin Timberlake's tweets?
Yeah.
We're going to assume so. We got random, done. 10%, done. What's next? Normal. All right, normal. Did the problem tell us that the population was normal? No. Is the sample size bigger than 30? No. But do we have to make box plots? No, because the problem told us that our box plots were good. So here's what we can do. We can just say both box plots have no outliers or strong skewness. So T procedures apply. Let's freaking go. Does anyone have any questions about plan? All right, now I have something very important to tell you guys before we move on to do. Right here on normal, you can look at each of the populations separately. So let's say it had told us that Katy Perry's population was normal and Justin Timberlake's box plot was normal for his sample data. That would have been fine. Or if Katy Perry, we had taken a sample of size 50 and Justin Timberlake had the box plot, that would be fine. Or if we had to look at Katy Perry's box plot and Justin Timberlake's population was normal, that would be fine. So it doesn't have to be the same thing for both. It can be a combination of any of the three. Does that make sense? Okay. All right. Last thing I want to make sure you guys understand about normal. If the sample size is bigger than 30, the box plot can be whatever it needs to. It can be outliered, it can be skewed, it can be whatever. Once you meet the qualification of population is normal, nothing else matters. Sample size is 30, nothing else matters. Even the box plot or the dot plot can be skewed and outliered as long as my sample size was bigger than 30. Okay? So once you meet that 30 qualification, the sample data doesn't matter anymore. That's only our last case scenario if our sample's less than 30. Cool? Great. Fantastic. Let's do the do. Man, y'all are into this today. Do. We're going to use a 2 sample t interval. We're going to use a 2 sample t interval. So that is in the calculator. Under stat test 0. Stat test 0. In our calculator under stat test 0. Now, your calculator is again asking you about inputs. Do you have individual data or do you have summary statistics? Yeah, we have stats. But I want you guys to know if you were given two different lists, you might have to put a list in L1 and a list in L2, and then you would use the data. But we have summary statistics, so let's go over to summary stats, and here we go. X bar 1, what is X bar 1? That is Katy Perry's mean number of likes, so 7193. S sub X1, 1749. N1, 15. X bar 2, 6393. S sub X2, 3407. N2, 15. Now it's asking you for the confidence level. What confidence level are we using? 95. Make sure you put it in as a decimal, 0.95. Now, there's this weird question about pooled. We are currently sitting in a classroom. Would it be a good idea for us all to go jump in a pool somewhere? No. Why not? No pool at school. You will not use pooled in this class. When you guys get into upper level stats, you might do pooled, but we never use pooled. So for pooled, you're always going to say no. Just say no to the pool, okay? No pool in school. No pool in school. Again, guys, when you hit enter or calculator, whatever the word is, please be patient. Don't click enter too many times. It will make it go away. So just be patient. Your calculator's doing a lot of work. It's doing a lot of work. All right, guys, you should have an interval. Now, this is the interval difference, Katy Perry's average tweet likes and Justin Timberlake's average tweet likes. Katy Perry's minus Justin Timberlake's is how we did this. All right, so what is your lower boundary for the difference in their number of likes on average? Negative what? Okay. And what is the upper value of their average number of tweet likes? Okay, so let's just think about this for a second. If I'm doing Katy Perry minus Justin Timberlake's likes on average, and I'm getting negative numbers, whose likes are more? Justin Timberlake's. But if I'm getting positive numbers, whose likes are more? Katy Perry's. Okay. But here's the biggest question of the whole day. Is it possible that they can have the same number of likes on average? Yes. How do you know that? Because zero's in there. Okay, cool. So we're going to actually write that down in just a second, but let's go ahead and conclude real quick. We are, what are we? We are 95% confident that the interval from negative 1257 to 2857 captures the true mean difference. Katy Perry minus Justin Timberlake. I'm just going to remind myself again what order we were doing it in. Captures the true mean difference in their tweet likes. Captures the true mean difference, Katy Perry minus Justin Timberlake, in their tweet likes. Now, the whole problem was about, is it possible for them to have the same average number? And the answer is yes, it's possible because of the fact that zero's in the interval. Okay, so we're going to answer that follow-up question here in just a second. Does everybody have this? Can I erase it? Nope, no, okay, not erasing it. So do we have convincing evidence of an actual difference? No, because zero is in our interval. That's what I'm going to write down when I get to it here in just a second. Okay, I got thumbs up, so here it is. No! Since zero is in the interval of possible difference values, we do not have convincing evidence that their likes are different. Because we saw in our interval, sometimes Katy Perry has more likes on average, sometimes Justin Timberlake has more likes on average, but the big thing is that sometimes it could be that they have the same likes on average because zero was in the interval. What questions do you guys have about that?